Oh, welcome back, guys. I'm so excited about this video. I'm going to prove that the derivative of sine x is cosine x. You guys are going to love this. But before we begin, we have to recall a few things. Now, I hope you guys remember that from my limit video, the limit as h approaches 0 of sine h over h is 1. And I hope you guys remember that the limit as h approaches 0 of cosine h minus 1 over h is equal to 0. And the most important thing is that I hope you guys remember that sine of 30 plus 45 does not equal to the sine of 30 plus the sine of 45. In other words, you're not allowed to distribute to the angles, okay? But you do remember the sum of two angles, let's call it x plus h, is equal to sine, cosine, cosine, sine, and then we're going to put the angles there. So you're going to put this one first and then this one next. You're going to do the same thing, and then whatever sine this is, you're going to put that there. So in other words, sine, cosine, cosine, sine, cosine, okay, and then sine h. So we're going to need this in order to do the f of x plus h part, okay? You're not allowed to distribute this. All right, f of x is equal to sine x. F of x plus h means every time I see an x, I'm going to plug in an x plus h. So that's that part. Now I need to expand it. Remember, you are not allowed to go sine x plus sine h. That is what we call illegal. Okay, next, you're going to expand it just how I expanded it here, okay? You're going to write down sine, cosine, cosine, sine. And then you're going to put the first variable, the second variable, the first variable, the second variable with the plus sign in the middle. So this is f of x plus h. Okay, you can pause the video if you need to, okay? Now, we're going to use the definition of a derivative. F of x plus h minus f of x over h. Remember the limit as h approaches 0. So this guy here is f of x plus h. That's from here, okay? That's from right there. I know you guys see it. You guys are smart. Here we go. Minus f of x, which is our original function, which is here. Great, all over h. Now, you're just going to have to maneuver it. One thing that's really great is that our denominator is just a monomial. Think about if you wanted to combine these two expressions. Isn't it true that it would just give you this guy up here? Okay, so I separated the h, and I put it both of them, and I took this guy right here, and I'm putting it with them because I see a sine x and a sine x. Okay, let me get a different color. I see a sine x and a sine x, and I'm about to factor that out. All right. So I'm going to put this and this here together with the minus, sorry. That goes here, and then I'm going to put the plus cosine sine x right there, sine h right there. All right, so I factored this out. I factor out the sine x, and I get sine x parentheses cosine h minus 1 all over h plus cosine x sine h over h. It's so important to see the variables. Sometimes it's an x, sometimes it's an h. The reason why that's important is because we're about to take the limit as h approaches 0. Hey, that's a 0. 0 times sine x is 0. Hey, that's going to be positive 1. The limit as h approaches 0 for sine h over h is 1. 1 times cosine x is cosine x. Okay? Whoa. Therefore, the derivative of sine x is cosine x, and you are done.